In this lecture, we are going to deal with the De Moivre's theorem of module number 1, Engineering Mathematics 1. The De Moivre's theorem for any real number n, one of the value can be written as of cos theta plus I sin theta whole power n should be equivalent to cos n theorem. If z is equal to cos theta plus I sin theta, then 1 upon z. Otherwise, z inverse can be written as cos theta minus I sin theta. Then cos theta minus I sin theta, the whole power n, also can be written as cos n theta minus I sin n theta. Then if z1 is equal to cos theta 1 plus I sin theta 1, and z2 is equal to cos theta 2 plus I sin theta 2, then z1 upon z2 can be written as cos theta 1 minus theta 2 plus I sin theta 1 minus theta 2. With the other application, you can write sin theta plus I cos theta the whole power n can be rewritten as in the form of cos n into pi by 2 minus theta plus I sin n into pi by 2 minus theta. So these are the De Moivre's theorem and its applications. Using this theorem, we will be seeing the problem, how to solve, how to simplify the complex terms, simplify the following, which is cos 5x minus I sin 5x the whole square into cos 7x plus I sin 7x the whole power minus 3 upon cos 4x minus I sin 4x the whole power 9 and cos x plus I sin x the whole power 5. For finding out the simplification of this case, first we are supposed to represent the separate terms as in the form of exponential for our convenience. So first we are supposed to represent the given terms in the exponential form, which is cos 5x minus I sin 5x can be written as e to the power of minus 5x. Same way, cos 7x plus I sin 7x can be written as e raised to I 7x, and cos 4x minus I sin 4x can be written as minus I e to the power of minus I 4x. Then cos x plus I sin x can be written as e raised to ix. So substitute all these terms in the respective positions and multiply with the power. So when we are combining the powers of e to the power of I minus 10 minus 21 plus 36 minus 5 into x we will get, which is e to the power of 0x, which is 1. So the simplified answer is 1. The same way we are having another complicated term for the second problem to simplify, that is 1 plus sine pi by 8 plus I cos pi by 8 upon 1 plus sine pi by 8 minus I cos pi by 8. The whole power 16 should be simplified. So first we will simplify the numerator part, which is 1 plus sine pi by 8 plus I cos pi by 8. Further, which can be written as sine pi by 8 as cos pi by 2 minus pi by 8. Same way, cos pi by 8 can be written as sine pi by 2 minus pi by 2 minus pi by 8. Then if you are simplifying the theta value, it becomes 3 pi by 8, which is 1 plus cos 3 pi by 8 plus I sin 3 pi by 8, we will have it. So when we are combining it, the first two terms, 1 plus cos 3 pi by 8 can be written as twice of cos square 3 pi by 16 plus I into the sine 3 pi by 8 can be written as twice of sine 3 pi by 16 cos 3 pi by 16. So when we are taking 2 cos 3 pi by 16 as a common term, then the remaining term you can write it as e to the power of I 3 pi by 16. The same way, denominator part, which is 1 plus sine pi by 8 minus I cos pi by 8 can be written as twice of cos 3 pi by 16 into e to the power of minus I 3 pi by 16. So substitute in the respective place and just simplify it. When we are simplifying, we are getting e to the power of 6 pi we are having it, which is equal to again 1. So 1 is a simplified answer for the given complicated term. So next, in the third sum, we are going to see the simplification part of the given three terms. The first subdivision, if you are considering 1 plus I the whole power 8 into 1 minus I root 3 the whole power 6 upon 1 minus I the whole power 6 to 1 plus I root 3 the whole power 9. So this term should be simplified as a single term. As you can see, the separately we are supposed to write down the given expressions as in the form of exponential form, because the exponential form always it is very easy to solve, it is very easy to simplify. So 1 plus I can be written as root 2 e raised to I pi by 4. To the power 8 we need, so to the power 8 we are taking on both the sides. So 2 to the power of 4 into e to the power of I 2 pi, we will have it. The same way 1 minus I to the power of 6 should be taken in the form of exponential part. Then we are getting 2 to the power of 3 e raised to minus I 3 pi by 2 as the expression for 1 minus I the whole power 6. The same way we are supposed to write it 1 minus I root 3 the whole power 6, which is again 2 to the power of 6 into e to the power of I 2 pi, and the negative sign we are having in the argument. Then 1 plus I root 3 the whole power 9 can be written as 2 to the power of 9 e raised to I 3 pi. So substitute all these things in the given term. Everything should be written in the form of exponential and take the powers of e. The 2 to the power, if you are considering 10 minus 12 we are having, then if you are considering the power of e, only minus 3 pi I by 2 is left out. E to the power of minus 3 pi I by 2. So which can be further written as 1 by 4 into cos 3 pi by 2 minus I sin 3 pi by 2, which when we are simplifying, that is sin 3 pi by 2 is 1 minus 1. So minus of minus it becomes plus 1. So plus I upon 4. So cos 3 pi by 2 value is 0. So we are leaving that as it is. The same way the second subdivision, if you are considering 1 plus 7 I upon 2 minus I the whole square, the whole power 4n should be simplified. First, we will simplify the term which we are having within the bracket, which is 1 plus 7i upon 2 minus I the whole square. So when we are simplifying it, the denominator part 4 minus 1 minus 4i we will have it, which is 3 minus 4i in the denominator. So multiply and divide by the conjugate, which is 3 plus 4i. Then again simplify. The simplified form we are having minus 1 plus I. So minus 1, the given expression can be written as minus 1 plus I the whole power n. Further, you can represent in the form of exponential part, which is root 2 e to the power of minus I pi by 4. So just take power 4 within the bracket so that we are having minus 4, which is e raised to minus pi we will have it, which is cos pi minus I sin pi. Cos pi value is minus 1, sin pi value is 0. So minus 4 will be there in the bracket. So the whole power 4. The simplified form of the second subdivision is minus 4 to the power of n. Then they are asking us to find out the simplified answer of 1 plus I the whole power 996 plus 1 minus I the whole power 996. Separately, we will write down the expressions as in the form of exponential form. There is 1 plus I the whole power 996 can be written as root 2 e raised to I pi by 4 the whole power 996. The simplified part you will have it 2 to the power of 498 into e to the power of I pi. After applying all the rotation angles and all, finally we are getting e raised to I pi. The same way you can get it for 1 minus I the whole power 996. The simplified answer is 2 to the power of 498 into e raised to minus I pi. Just we are supposed to add it together. So 2 to the power of 498 you can take as a common factor. Then within the bracket e raised to I pi plus e raised to minus I pi will be there, which can be written as twice of cos pi. Cos pi is -1, so negative sign. 2 is there, so 2 to the power of 499 is a final answer. For the third subdivision, the simplified answer is -2 to the power of 499. So this is all about the applications of De Moivre's theorem.